Okay, this is 4.4, graphing sine and cosine. So we're going to look at sine, and you're going to think back to your unit circle where you had 1, 0, 0, 1, negative 1, 0, 0, negative 1. And all your sine values are going to be your y values. So at 0, so when sine is 0, I have 0. So on my graph at 0, my sine is going to be 0. At pi over 2, which is this one up here, my sine value is going to be 1. So at pi over 2, my y value is going to be 1. At pi, my y value is going to be 0. So we're back down to 0. At 270, or 3 pi over 2, my y value is negative 1. And then we're back up to 0. And so if we connect these, our graph for sine is going to go 0, 1, 0, negative 1, 0. And it's going to be curved. Don't make it like a V-shape kind of thing. And this is what we call one period. It takes you 2 pi to go through the whole entire circle before we actually repeat the pattern. And so in your head, just think that your pattern is 0, 1, 0, negative 1, 0. And that's just all of your y values. So that is our basic sine graph for one period. And for sine and cosine, I'm only going to have you graph one period. Now we're on to cosine. I'm going to do the same thing. I'm going to do your 1, 0, 0, 1, negative 1, 0, 0, negative 1. And all my values are going to be, not the y, they're going to be the x because we're dealing with cosine. And so at 0, my cosine is 1. At pi over 2, my cosine is 0. At pi, my cosine is negative 1. At 3 pi over 2, my cosine is back up to 0. And back at 2 pi or 360, we're back up to 1. So it kind of looks like a bowl. And so my graph goes 1, 0, negative 1, 0, 1. And it'll keep repeating that pattern. And so my period for a cosine graph, it takes 2 pi to go through one whole entire cycle of the graph before it starts to repeat the pattern. And my pattern that you just kind of need to remember is 1, 0, negative 1, 0, 1. That's your basic pattern for a cosine graph. And so both sine and cosine are going to have a period of 2 pi, and you just need to learn the patterns. And if all else fails, go back and draw this again, and you can get all your values from that. Next, we're going to basically just go back and review your transformations. However, they're going to be called some slightly different things when you deal with a trig equation. The A is your amplitude. That basically is how far you are from the midline of your graph. It's not from top to bottom, it's from the middle of the graph up or the middle of the graph down. Also keep in mind, if you have a negative out here, that's a vertical reflection. So that means it's basically going upside down. And then the trig basically just means any trig function. Could be sine, cosine, tangent, secant, cosecant, or cotangent. The b, when you do 2 pi over b for sine and cosine, and then cosecant and secant later that we'll do, tangent and cotangent are slightly different. That basically gives you the period of your graph. That tells you how far from the beginning of one cycle to the end of one cycle your graph is going to be. So it'll either make it bigger or smaller depending on what number you have in there. And just like we've done before, the C is you're moving right and left. We call this a phase shift. And if it's a minus, you go right. If it's a plus, you go left. And let's find purple. And then again, lastly, we call this a vertical shift. If it's a plus, you go up. minus you go down. Now we won't be doing any horizontal reflections, we'll just do vertical reflections on these. Okay, first example problem, y equals 4 sine of 2x. So my amplitude comes from the 4, so that's my amplitude. My length of my period, you're going to take this number that's in front of x, do 2 pi divided by that number. So my length from beginning to end is going to be pi. If you'll notice, there's no movement left or right, no movement up or down, so I have no phase shift, no vertical shift. Then I'll ask you for the beginning of your point of your period and the end point. That helps you do your graph. So you're always going to start, your phase shift and your beginning point are always going to be the same. So wherever your phase shift is, that's where your graph is going to start. And then you're going to add to it the period. And in this case, your period is pi. So if I do 0 plus pi, my graph will end at pi. So we did a basic one. This one's kind of common sense. So you're starting at 0 and you're ending at pi. So on my graph, I'm going to draw in the x-axis. I'm not going to draw in the y-axis yet, only because on some problems, it's better off. Now, obviously, I know we start with 0, so you could do it now if you wanted to, but usually it's easier just to draw that in later. So I'm going to basically kind of mimic the 4 quadrants that you have on your parent graph. So you're going to basically start here, 1, 2, 3, 4, 5. So there should be 4 sections. This is kind of mimicking quadrant 1, quadrant 2, quadrant 3, quadrant 4. So you're going to separate it into 4 pieces. Please, when you're doing your homework, do not do them one at a time. At least go by 2s, if not by 3s. And so this first one is where you're going to start. This is where you're going to end one period of your graph. So I'm starting at 0 and I'm ending at pi. I also, before you even draw the graph, I want you to mark what all of these are. So these should all be spread evenly apart. So it's kind of like you're doing averages. If I do 0 plus pi and divide by 2, I'm going to get pi over 2 for the middle. If I add pi over 2 and pi, which is 2 pi over 2, pi over 2 plus 2 pi over 2 divided by 2 is 3 pi over 2 divided by 2, which is 3 pi over 4. And then between 0 and pi over 2 is pi over 4. So I can draw in, since this is 0, I can draw in my x-axis here. So then for graphing, let me change this to red, okay, you're going to mark, and I would use a highlighter for this. Let me change colors on this. I want a highlighter color. Let's use this one. Okay, you're going to mark your 2 phase shifts, and so your 2 shifts, sorry, your phase shift and your vertical shift. And in this case, since they were both 0, I'm just going to mark them on here just for a visual, because I'll do it on the other one. And this is where you're going to do your sign pattern from. Now, normally, your sign pattern would go 0, 1, 0, negative 1, 0. But since this is an amplitude of 4, you're going to go 0, up 4, 1, 2, 3, 4, back to 0, down 1, 2, 3, 4, back to 0. Because your original pattern was 0, 1, 0, negative 1, 0. So when you multiply by 4, you get 0, 4, 0, negative 4, 0. And then there is your sine graph, that 4 sine of 2x graph. Next one, I have negative sine of x, pi x over 2 plus pi over 2 plus 3. So before you do anything, you need to factor out your pi over 2. That gives me x plus 1 plus 3. So my amplitude, let me change my colors. My amplitude, since there's nothing here, and the easiest thing to do is just account for your amplitude here, negative 1, so that you remember to flip it upside down. If you put 1, that's fine, as long as you remember when you do your graph to flip it upside down. My length of my period, so since there is a pi over 2 here, you're going to do 2 pi over pi over 2, which is 2 pi times 2 over pi. The pi's cancel, and your period's going to be 4. So sometimes you're going to have numbers where your x-axis is radian measurements, like pi over 2, pi over 4, pi over 3. And then sometimes you're going to have numerical values for your x-axis. It really depends on the problem, and when we start doing sinusoidals later, you'll see why sometimes you need to have numbers on it. And then my phase shift is going to be, if it's a +1, you're going 1 left, or you can say -1. Doesn't make a difference as long as you understand the difference. And I'm going up 3. So my graph is going to start at my phase shift, so it's going to start at -1. If I start at -1 and add the length of my period, you're going to get 3. So basically your end point is equal to your beginning point plus your period, if you need to kind of remember that. So on my graph, I'm not going to put in my y-axis yet because I need to figure out where it is. Here's -1, 1, 2, 3. Mimic my 4 quadrants, I go to 3. And then I'm going to do averages again. -1 plus 3 is 2. 2 divided by 2 is 1. And then you can kind of tell, in the middle of 1 and 3 is 2. In the middle of -1 and 1 is 0. So my y-axis goes here. Then I'm going to mark, let me change my color to a highlighter color. I'm going to mark, that's not really, I'm going to mark my 2 shifts. So I'm going to kind of mark -1, and I'm going up 3, 1, 2, 3. And so when I go to graph my graph, instead of drawing it off of the original, I'm going to draw this off of this kind of translated axis. So instead of me drawing in the graph and then moving it, I'm moving the axis first. You're kind of go off of this. So now my amplitude is -1 and it's sine. So remember, my sine pattern is 0, 1, 0, -1, 0. So if I multiply this whole thing by, by -1, I'm going to get 0, -1, 0, 1, 0. This is going to be the pattern I'm going to plot. So I'm going to plot 0. And when I say 0, I'm talking in reference to this translated axis. So I'm going to plot 0, -1, 0, +1, 0. That way it's been flipped upside down. I've already taken into account my horizontal stretch or shrink, and I've taken into account my moving left 1 and up 3.